Good morning, students. This video lesson is on chapter 2, atmosphere, and today we are going to learn about the composition, and structure of the atmosphere. So our atmosphere basically surrounds our earth, and this atmosphere is made up of what things that we are going to learn. So, what is atmosphere? It is a mass of air surrounding the earth. This is the definition of atmosphere. So, mass of air surrounding the earth is known as atmosphere and is divided into 5 distinct layers. So, it is divided into 5 distinct layers. Based on that composition, temperature is this one, and density. Now, density of the gases. So, which gases are found in what quantities in these layers? So, based on the composition of the gases, as well as the temperature, as well as the density of the gases, that makes of these layers. They are basically divided into 5 layers, The major gases that surrounds our atmosphere are permanent gases and variable gases, as well as aerosols and water vapor, which I taught in the previous lesson. The major gases that surrounds our atmosphere up to a height of 32 kilometers. So up to a height of 32 kilometers, which gases are found in the atmosphere are permanent gases and variable gases. That is up to stratosphere, up to this layer called the stratosphere. The first layer is called troposphere, the second layer is called stratosphere. So up to this layer, which gases are found? They are basically permanent gases, which are known as nitrogen, oxygen and argon, and you can know them by the abbreviation NOAA. So you can also know it as NOAA. And OA, NOAA. And variable gases are basically, or changeable gases are basically carbon dioxide, neon, helium, krypton, xenon and hydrogen, which are found up to stratosphere. You find water vapor also, as well as dust particles in this layer. So, our atmosphere composition is made up of many gases. So, a lot of times, students think that oxygen is one of the major gases that is found in the atmosphere as we use it for breathing. But if you look at the percentage of nitrogen and compare it with the oxygen, the most predominant gas that is found in our atmosphere in large quantity is basically nitrogen. So, let's come to the 5 distinct layers, which are basically, differentiated on the basis of composition, temperature and density of the gases. So, they are namely, the nearest and the closest layer is known as troposphere. The first one, the second one is stratosphere, the third one is mesosphere, and the fourth one is thermosphere, and the fifth one is exosphere, And their respective distance from the earth, you can see it here, Troposphere distance from the earth is basically from 8 to 18 kilometers. Then stratosphere 18 to 50 kilometers, then mesosphere from 50 to 80 kilometers, then thermosphere 80 to 450 kilometers, and exosphere from 450 to outer space. Outer space means it merges with the outer space. Which I will explain you in the later class in detail. Now, if you look at this diagram, I have drawn the temperature also. I have drawn a temperature also, which I have represented by a red line. This is known as temperature. Temperature, temperature. Now, temperature means degree of hotness or coolness in the air. Or degree of hotness or coldness in the atmosphere is known as temperature. Now, I have shown you temperature also, here. Now, if you look at this temperature varies a lot in the atmosphere. Sometimes it rises, sometimes it decreases. Okay. Therefore, I have drawn a red line to represent temperature and the altitude. So, it not only shows the temperature, it also shows the altitude, 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 okay, of a particular, okay, layer. As you know that if you are standing here, on the surface of the earth, and as you move upwards, okay, to the, okay, upper layers of the troposphere, what happens? Not only the pressure of the air decreases, but also the temperature decreases or increases with height. So here what happens is, if a man basically climbs or basically, okay, goes away from the earth or moves away from the earth's surface, what happens? What happens is the pressure of air also decreases. Pressure of air also decreases with, okay, temperature. So pressure of air decreases as well as temperature decreases, okay, with increase in height. With increase in height. So as you are moving away from the earth, and if you are going up, what happens? The pressure of air or the density of the air also decreases as well as the temperature decreases. So here we come to know, so in the troposphere, temperature decreases as the altitude increases. So in order to show this, I have drawn this line. Okay, so I have drawn this line. So I'll make a graph here. Okay, and I'll make this line. This line is a negative relationship, which shows a negative relationship, which shows decrease, of temperature with the increase in height. Okay, so in the troposphere, temperature decreases as you go away from the earth. So at the higher level of the troposphere, what happens is temperature decreases. So as a person basically goes away from the earth's surface, what happens? The temperature decreases with the increase in altitude. This also happens here in the mesosphere. Here you can see, okay, if a person is climbing up, here also we have the same thing, okay, temperature decreases with the increase in altitude. So one thing you have to understand is, in troposphere and mesosphere, okay, what happens when you are going away from the earth? Okay, temperature, okay, decreases, okay, with height. Whereas if you look at the stratosphere and thermosphere, okay, you find there is another graph, okay, which shows, okay, an increase. Okay, so this shows the increase, not decrease, increase. So it is a positive relation. It shows a positive relation where you find in the stratosphere, and, okay, thermosphere, okay, temperature increases with height. Now you have to understand this. In troposphere and mesosphere, temperature decreases with height. In stratosphere and thermosphere, temperature increases with height. Now, why the temperature increases here and why the temperature decreases here? Okay. Now, temperature decreases here, okay, in the troposphere and in the mesosphere because this is the coldest place. Here, the troposphere is closest to the earth, okay, and as you can see, all the gases that is found in the troposphere is held by the gravitational pull of the earth, okay, and as well as the sun's heat. Basically, during the night time, it is absorbed by the earth, but as you move away from the earth, the temperature decreases. But here in the stratosphere and thermosphere, you don't find the same. Because in the stratosphere, it is the ozone layer. Ozone layer is the layer, okay, you have an ozone layer in the stratosphere. In the ozone layer, what happens is the ozone layer basically protects our earth from the harmful rays of the sun. It basically absorbs the heat and this layer becomes a little bit hot or warm. Therefore, temperature increases. What about thermosphere? Now, thermosphere is made up of ions, okay, electronically charged particles, or what we called, okay, electrons or ions, okay, and they are basically, the thermosphere is the hottest layer. As well, therefore, this layer is hottest because it has got ions, and ions basically increases the temperature of that particular layer. So temperature basically increases in thermosphere as well as in stratosphere. But temperature also remains constant in some of the layers. Now, I have marked here this line. This line. Can you see these lines on the blackboard? You can see there are three lines, okay? These are the topmost layer or the uppermost limit of the troposphere, the uppermost limit of the stratosphere, the uppermost limit of the mesosphere is called by different name, okay? The uppermost limit of the mesosphere is known as mesopause, okay? The uppermost limit of the stratosphere is known as stratopause, okay? And the uppermost limit of the troposphere is known as tropopause. In this layer, the temperature remains constant, okay? The temperature remains constant in these zones, in the stratopause, in the mesopause, and in the tropopause. The temperature stops decreasing with height or stops increasing with height. These zones are the upper limit of the troposphere, stratosphere, and mesosphere. So this is the only layer in which the temperature remains the same, because this becomes the uppermost limit and the coldest place, okay? Now we are moving on to the first layer, that is called troposphere, okay? Now I am drawing the same earth, okay? Now let's make a earth, okay? Then I'll make a person here, which is living here, and I'll make some trees, okay? Now I'll make the upper limit of the troposphere, okay? This is known as pause, which basically starts from 18 to 18 kilometers. So basically, tropopause starts from here and ends up to here. This is the upper limit of the troposphere. This is known as tropopause. Now, I'm going to write some points. I'm making clouds also. Clouds, okay. I'm making birds also, okay. I'm making mountains also, okay. Now, if you look at this troposphere, it starts from the earth and ends here. So what we call their respective distance from the earth is from 8 to 18 kilometers. Now troposphere is the closest layer to the earth and is also known as a region of mixing. It is also known as a region of mixing, which I'll come later on and explain you. And it is one of the lowest layer of the atmosphere. It is the closest layer and the lowest layer of the atmosphere. It is the first layer. The thickness of this layer is not uniform, as its upper limit is higher, that is 14 kilometers above the equator than above the two poles, that is 8 kilometers. Now if you look at this troposphere, now I'll make a small diagram here, so that you can understand. Now if I make a earth, round shape of the earth, and if I make a troposphere, now the thickness of the troposphere is smaller in the poles than as compared in the equator. Now this is equator, this is north pole, and this is south pole. Now if you see the thickness here in the poles, you find it is only 8 kilometers. But in the equator, you find it is 18 kilometers. What is the reason for this? In both sides of the equator, you find 18 kilometers, the thickness of the troposphere, which surrounds our earth. But if you look at the poles, it is only 8 kilometers. What is the reason for this? The reason for this is the height of the troposphere is more in the regions where the amount of heat received is more. So the height of the troposphere is more in the places where the heat is more. If the heat is not more, then you will find the height of the troposphere is less. It is due to what? Due to the rays of the sun. You have direct rays of the sun in the equator. Therefore, you find that the thickness of the troposphere in the equator is more as compared to the poles, because the poles receive the slanting rays of the sun. Therefore, you find the thickness of the poles is much smaller than as compared to the equator. Heat difference on the surface causes convection currents of air to flow from equator to the poles. In tropics, in tropical regions, that is in the Tropic of Cancer and Tropic of Capricorn, you find the height of the troposphere is more as compared with the colder regions, which causes change in the height of the troposphere. Now, another point that you have to understand is, it is one of the densest layer, D-E-N-S-E-S-T, densest layer. It is one of the densest layer, that is 75% of the total mass of the atmosphere is found in the troposphere. Which means troposphere contains most of the atmosphere mass, or in other words, it is the most densest layer. And that makes sense also. Why it is called the densest layer? Because it is due to gravity. This densest layer is due to gravity of the earth. Because the gravity of the earth basically pulls all the gases that is found in the troposphere nearer to the surface of the earth. Nearer to the surface of the earth or closer to the earth, and the earth gravity is stronger as you get closer to the earth. This is the reason why you find all the gases are found in the troposphere near the surface of the earth. Therefore, it is called one of the densest layer of the earth. Now, troposphere is also called by another name. In a literal sense, it is called the region of mixing. Now, but what is mixing that? It has been derived from the Greek word, this word name T-R-O-P-O-S, tropos. Tropos means a Greek word which means mixing, in English. Or turbulence, T-U-R-B-U-L-E-N-C-E, turbulence. It also means turbulence. Because in this troposphere only we find the oxygen which helps us to breathe, the air we breathe. And almost all dust particles are also found in the troposphere, as well as water vapor is found in the troposphere, okay? And all weather conditions like clouds, okay, snow, rain, fog, storm occurs in this layer due to the presence of water vapor. Therefore, I made clouds here. Now, clouds are not found in the lower layers of the troposphere. It is found in the upper layers of the troposphere as well as in the stratosphere. Remember that. Now, clouds are made by water vapor. Mixing of water vapor plus dust particles makes clouds. And cloud is the reason for rainfall. But cloud is made from water vapor. And water vapor is the reason for the rainfall also. So, water vapor basically is a liquid in a gaseous state, which basically drops from the sky in the form of rain. That is precipitation, snow, hailstone, etc. All these things or weather conditions basically happens in the troposphere. Therefore, it is called the region of mixing or the region of turbulence also, because you have storm, lightning, thunder, etc. in this area only. You have black clouds, okay. There are different types of clouds. Cirrus clouds, okay. Cumulonimbus clouds, etc., which brings rain, etc. This happens in this layer. Therefore, it is called the region of mixing. This layer also protects us from extreme heat during the day. During the day, this layer also acts like a blanket, protecting the earth from the extreme heat during the day, and also traps terrestrial heat during the night, which keeps the earth warm during the night. What do you mean? Okay, with this I have finished some of the main topics like troposphere. In the next class, I'll be teaching you about temperature and pressure, how it decreases, and we'll move on to stratosphere. Thank you for listening.